In the previous video, we talked about DO-178C, the standard for aircraft software. But software is only one part of the system. Aircraft systems are much larger and much more complex. They include hardware, software, and system-level interactions. So the question is, how is the entire system developed? This is where ARP4754B comes into play. It defines how aircraft systems are developed, integrated, and validated. In this video, we explain what ARP4754B is, how it works, and why system-level thinking is essential in aviation. Why does ARP4754B matter? Aircraft systems are highly complex. They consist of multiple components, including software, hardware, sensors, and human interaction. All these elements must work together seamlessly. A failure at system level can have severe consequences, even if individual components are working correctly. This makes system-level thinking essential. It is not enough to develop components in isolation. The entire system must be designed, integrated, and validated in a structured way. And this is exactly what ARP4754B provides. So what is ARP4754B? ARP4754B is a guideline for the development of aircraft systems. It covers the entire system lifecycle, from initial requirements to integration and final validation. Unlike software-focused standards, it looks at the complete system. This includes both hardware and software, as well as their interaction. The focus is on ensuring that the system behaves correctly in its intended environment. ARP4754B is also closely linked to certification. It provides the framework to demonstrate that a system meets its requirements. So, how does system development work under ARP4754B? The process follows a structured life cycle. It starts with system requirements, where the expected system behavior is defined. Then the system architecture is developed to define how different components interact. This is followed by detailed design, where the system is broken down further. After that, the components are integrated, and finally, the complete system is validated. A key aspect of this life cycle is its top-down approach. At the same time, verification is performed continuously, across all stages. This ensures that the system meets its requirements at every level. A key step in system development is the allocation of functions. At the system level, functions are first defined based on requirements. These functions are then assigned to specific components. Typically, this results in a separation between hardware and software. Some functions are implemented in hardware, others in software. This allocation is critical because it determines which development standards apply. Software components, for example, must follow DO-178C. Hardware components are developed according to standards such as DO-254. This enables parallel development while ensuring consistency at system level. So how does ARP4754B relate to DO-178C? ARP4754B defines the development at system level. It starts with system requirements and defines the overall architecture. From there, requirements are allocated to software components. This is where DO-178C comes in. It governs how the software is developed and verified. So, DO-178C operates within the framework defined by ARP4754B. A key aspect is consistency. Requirements, architecture, and software must all be aligned, and verification and traceability must be maintained across all levels. System development is closely linked to safety assessment. While ARP4754B defines how the system is developed, ARP4761A focuses on safety analysis. It identifies hazards and evaluates potential failure conditions. This directly influences system requirements. So safety is not a separate activity. It is tightly integrated into system development. System information flows into safety analysis. and safety requirements flow back into the system design. This creates a continuous loop between development and safety. What challenges arise in practice? One of the biggest challenges is managing system complexity. Aircraft systems involve multiple disciplines that must work together. Coordination between hardware, software, and safety is not trivial. Another challenge is defining complete and consistent requirements. At system level, everything must fit together. Traceability is also critical. All elements must be linked across different development levels. And finally, there is alignment with certification expectations. Meeting all these requirements requires a structured and disciplined approach. There are several common misunderstandings about ARP4754B. One of the most common is that it is just about documentation, but in reality, it defines the entire system lifecycle. Another misconception is that system development is only about integration. In fact, it starts much earlier, with requirements and architecture. Some also believe that safety is handled separately, but safety is tightly integrated into system development. Another common misunderstanding is that software standards are sufficient, but system development requires coordination across multiple domains. Let's summarize the key points. ARP4754B defines how aircraft systems are developed. It covers the full lifecycle, from requirements to final validation. It integrates multiple domains, including hardware, software, and safety. A strong focus is placed on structure, traceability, and consistency. All of this is required to ensure that the system behaves correctly. And ultimately, ARP4754B is essential for the certification of aircraft systems. If you want to go beyond this introduction to ARP4754B, we offer a wide range of online training programs on our website. In aerospace, we cover system development, software standards like DO-178C, and safety assessment according to ARP4761A. In automotive, we provide training on functional safety, SOTIF, cybersecurity, and development processes such as ASPICE. We also cover medical devices, where safety-critical development and regulatory requirements play a key role. All courses are designed to be practical and applicable in real engineering projects. You can find the link in the video description and in the pinned comment below. If you found this video helpful, feel free to like and subscribe. We regularly publish content on safety-critical systems and engineering standards. Thank you for watching, and see you in the next video.